Hey everyone, this is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Please, before we go into today's exercise, do not forget to like, share, subscribe, and click on the notification button so that you can have more of my video. Today, we are taking a topic under physics, and the topic is taken in relation to electricity. And under this electricity, we want to obtain the parameter that we use to, evaluate the electromotive force that is generated by electrical generator. Before we derive this formula concerning the value of how to calculate the electromotive force from a generator, we should have the background of what is called the magnetic field and the magnetic flux. What is there is this: when we have a magnet, let's say this is a magnet, it will generate what is called magnetic field. Magnetic field is the region of phase of the space where the influence of the magnetic force can be felt. Let's say these are the magnetic line of force. Now, if this line of force enter this surface area, let me call this surface area A. This surface area A. Now, the number of lines of force that is entered per unit area is given as this magnetic field B. So in a nutshell, magnetic field B is given as the number of lines per unit area, which is magnetic flux divided by area. This area is perpendicular, is at right angle to the magnetic lines of force. But if this area is oriented at an angle theta, so instead of this area being vertical, I shift this area at an angle theta here, like this. If the initial area is A, I can have the component of this area along this angle theta. And the component is given as A cos theta. So in a nutshell, the magnetic field B, when the area is inclined at an arbitrary angle theta, is given as the magnetic flux divided by A cos theta. Just have the background of this. Now, we talk about electric generator. It has been observed that electricity can be produced when we allow a conductor to move in a magnetic field, or when we allow the magnetic field to be changing per unit time. The electricity will be generated in that conductor. So this process is known as electromagnetic induction, and this induction is credited to a scientist named Faraday. According to the experimental result by Faraday, look at this. Faraday says something. He observed that the electromotive force produced is equal to the number of turns of coil, then times rate of change of the magnetic flux. That is magnetic flux per unit time. Now, this electromotive force is what allows the electric current to move within the conductor. So what am I trying to say is this: if you allow a conductor like this, let's say this is a loop of wire. Let's say this is a loop of wire. This is a conductor, or we call it a loop of wire, and the number of turns is n. The number of times we move the turn, and you allow this particular magnetic field, and we are changing this value of the magnetic field in respect to this conductor. Electricity will be produced, electric current or electromotive force will be produced. That's just the idea of magnetic induction. So this concept is what the electric generator is using to produce electricity. Now let me say I have a generator here. This generator actually has this particular loop of wire inside it, and it has a magnetic field inside too. So when this loop of wire is rotated, as in a power station, when this loop of wire is rotated, because the electricity that we are enjoying in the city is being produced due to the fact that a conductor is being allowed to rotate between the magnetic field, and because of that electric current will be generated. So as this particular conductor is rotating, these are the magnetic pole, north pole and south pole. As this conductor, this is a electric conductor or coil or loop. So with that we either refer it to as electric conductor or coil or loop. So as this thing is rotating, electromotive force will be generated. This electromotive force is what we have here, and it has this particular sinusoidal form. The production is in this form. So we have this electric this thing per unit time. It's a changing value. So now we want to find an expression for this concerning this electromotive force in a generator. Now what we need to do is this. We know that we should realize something, that the magnetic flux that is flowing, the magnetic flux that is flowing, because this thing produces a magnetic flux here. Experimentally, when it was grabbed against the time t, it was observed that against the time t, it was observed that when the time was 0, it has a maximum value here. So during the experimental procedure, this particular graph that look like this is obtained, and this graph that we have is a cosine graph. It's a cosine graph. So if you remember the trigonometry, remember that in trigonometry, when we plot y against theta, and we have a sinusoidal form like this, we normally have our y to be amplitude sine theta. But for this particular instance, instead of we having this y, we are having the electric flux. And electric flux experiment does not produce a sine curve, it produces a cosine form. So in a nutshell, this electric flux now is equal to, instead of this y, is equal to the maximum value that we have here, flux maximum. Then it's going to be cos theta. So this is the function. This is the flux function. The flux function now, I want to rewrite it like this, is equal to the maximum value of this flux, cos theta. And another thing I want us to realize is this: if we want to get this expression for the electromotive force produced by the generator, according to Faraday, we need to find the derivative of this with respect to time. But we are having theta here. So what we need to do is this: recall that angular velocity is given as angular displacement divided by time. So that is angular displacement theta in radian, when we cross multiply, is going to be omega times t. So I'm going to replace this theta with this space. The reason is that if I want to obtain this value of electromotive force produced by the generator, I must have a rate of change of electric force with respect to time. But I'm having theta here. So what I'm going to have now is the maximum value of the flux cos omega t. Now, this particular maximum value of the cos, I can replace it with the magnetic field that we have here. If you make this flux subject to formula, I have AB. So the flux now, from the relationship between magnetic field and flux, is given as a magnetic field times surface area of the coil. So I'm going to replace this one with this maximum value. So what I'm going to have now is our magnetic field times area, then cos omega t. Now, to obtain this electromotive force, I need to do changing flux divided by changing time. So I have the derivative of flux with respect to time, that is dt. is equal to magnetic field times surface area of the coil. And if you are differentiating this with respect to cos, we are going to have minus sine omega t. Please, I need to refer you to the calculus. Then times omega. So this omega now, we take it here. So we are going to have it as a dA omega sine omega t. So now, for us to get E, I need to multiply this. This is minus. This minus, I put it here. For us to get electromotive force, I need to multiply both sides of this equation by minus n. So that means electromotive force E now will now be minus n times change in flux divided by change in T. Then we multiply both sides by the same thing. That is minus times minus give us plus. So this one becomes NBA omega sine omega t. So this is the standard formula for the electromotive force produced by electric generator. Let me rewrite it. That is a electromotive force E is given as the number of turns of the coil times magnetic field times surface area of the coil times angular velocity sine omega t. Now, if you want to obtain the maximum value of the electromotive force generated, electromotive force maximum, at that point, the value of sine omega t becomes 1. The reason is that omega t becomes 90 degrees, which is same thing as pi divided by 2. So at that point, when omega t equals angle 90 degrees or pi divided by 2 radian, the value of sine omega becomes 1. So for this one to be maximum, we are going to have this. I will write it like ban, then W. So this is the formula for the maximum electromotive force produced by electric generator. So please, this A, let me say this is the coil. The surface area of this coil is the A. Then this N is the number of times that I coil it. That's the number of turns of the coil. So the angular velocity is the amount of rotation, angular rotation per unit time of this coil inside the this particular magnetic field B. So I believe that you must have learned one or two things concerning the production of the electromotive force. All of us use electricity at home. Just remember something, that electricity can be produced apart from electric battery and cell. We can also use a mechanical method of production. So this generator is a mechanical method of producing electricity. How? By allowing a conductor to rotate within a magnetic field, or by changing the value of that magnetic field with respect to the conductor. Thank you for watching. Please, again, I'm going to do another video concerning an exercise on how to use this formula to solve problem. Thank you for watching. Have a nice day. Bye.